Welcome. In this video, I'm going to go over a magical projectile motion problem. So Disneyland, located in Anaheim, California, is famous for its spectacular nightly fireworks show. Barring any weather issues, the fireworks light up the sky around 9:30, dazzling visitors along Main Street, USA. Tonight, a firework is launched from the ground near Sleeping Beauty's castle with an initial speed of 250 feet per second at an angle of 70 degrees. The firework follows a parabolic path soaring over the crowd and illuminating the night. This is what I mean by it's not very safe. Normally, the fireworks definitely do not go over the crowd on Main Street. So let's figure out how long does it take this firework to reach its maximum height. So our vector valued equation we can use to describe projectile motion, r of t, is equal to an x component of v naught, so that's the initial velocity, cosine theta times t, comma. Now the y component is y naught, that's the initial height, plus the initial velocity times sine of the angle t minus 1/2 gravity times t squared. Now we can think of this as x of t, comma, y of t, where the x of t provides us our horizontal motion, and y of t provides us our vertical motion. So before we do any work, let's figure out what we actually have. We know that that's still under highlighter mode, our initial velocity is 250 feet per second. Our angle theta is 70 degrees. And let's see, what else do we know? So we have this part, and it was launched from the ground. That's important. That tells me that y naught is 0. That's the initial up and down height. Oh, and we're missing one last thing. Gravity is 32 feet per second squared, or 32 feet per second. So we're ready to set up our problem. Here is Sleeping Beauty's castle, and the firework is shot directly from the front of Sleeping Beauty's castle in that direction. I mean, Main Street's technically in front of it, but I did not find a sideways picture. So there you go. We're pretending this is facing Main Street here. There we are. So that's Main Street. And we're interested in the maximum height. We're actually interested in how long it takes this firework to reach its maximum height. So now if this were graphed on an xy plane, so here's x, here's y, the maximum here would occur at a particular ordered pair, and that ordered pair would be time, comma, y evaluated at that time. That would give us the height. So we need to find where this maximum occurs. So we can do that using methods from Calc 1. So first, let's set up our function for height. So y of t is equal to y naught, and I'm using this function right here. So y naught, our initial height off the ground, we already know is 0. So this is 0 plus our initial velocity of 250 times sine of 70 degrees. And again, I'm just taking the information we teased out of the question, minus 1/2 times 32 t squared. So this is y of t is equal to negative 16t squared. Oh, I'm missing something right here. I forgot my t. Let me quickly remedy this. There we are. So 16t squared plus 250 sine 70 degrees times t. So to solve this problem using calculus, to find the max, let's go ahead and set y prime, the first derivative, equal to 0. Remember, you have a max when the first derivative is equal to 0. Let's go ahead and find the first derivative. Y prime of t is equal to negative 32t plus 250 sine 70 degrees. Setting this equal to 0, we have 32t is equal to 250 sine 70 degrees. So t is equal to 250 sine 70 degrees divided by 32. Please take a moment to work out what this is approximately on your own calculator. Okay, on your own calculator, you should have 7.341349. That's to 6 decimal places. We don't need that much. So this tells us it takes about 7 seconds, a little over 7 seconds, like 7 1/3 seconds to reach its maximum height. All right, now let's answer another question. How high does the firework travel before it explodes? Well, remember, it's vertical, vertical, not vertical. Its vertical motion is given by the y component here, which we have right here. So we need to evaluate this. That is, we need to evaluate y when t equals 7.34. And be warned, even though I just write 7.34 here, on my calculator, I'm using the exact value. So if you're using a calculator, which you should be, make sure you use all the decimal places from your calculator. If you don't know how to do it easily, come chat with me in office hours. Okay, so y of 7.34 is equal to negative 16 times 7.34 squared plus 250 sine 70 degrees times 7.34. And go ahead and pop this into your calculator, again, using more decimal places than I'm showing you right here. You should get about 862.326359. And again, that's the 6 decimal places. Okay, so the firework will travel. So it will travel how high? That is, it'll reach a max height of about 862.33 feet. All right, we're on to the last question. How far along Main Street, USA, does it travel horizontally before reaching its maximum height? So remember, our horizontal motion is given by, that is the left and right motion. Horizontal is given by the x component. So we're going to use the fact that x of t is equal to v naught cosine theta t. So x of t is equal to 250 cosine 70 degrees times t. And from our last question, we know that the max height occurs at about 7.341 seconds. I think I've just been using a 2 decimal places, so let me stick with that. So we're going to evaluate x of 7.34. And now while I'm only writing it down to 2 decimal places, I'm actually putting it in basically all the decimal places my calculator gave me. So don't round until the end, please. And this is what you're going to put in your calculator. So 250 times cosine 70, times 7.34 to get x of 7.34 is approximately, take a moment to pop this into your calculator, please. So it's approximately 627.722275 feet. Okay, let's go ahead and write this down. We'll travel horizontally about 627.72 feet before reaching its max height. And we can summarize everything we found here. So we found this distance here from the start, there we are, from its start here. We figured out that's 627.72 feet. We also figured out that this max distance, max height that is about 600, oh, excuse me, no, 862.33 feet. And this occurs when t is equal to about 7.34. And if you're wondering where along Main Street this would be, Well, Google Maps can help us with this. There we are, there's Sleeping Beauty's castle. Okay, and I want directions. I want walking directions. And let's see, we know it will travel horizontally 627 feet. And a conversion, which you guys can do on your own or trust me on this, it's about 0.11 mile. So let's see. I'm going to guess at this. Let's see all the way to the railroad. So let's go to railroad. Oops, excuse me, Disneyland Railroad right here. And you can see that's 0.2 miles. So actually, it's a little over halfway. So Carnation Cafe seems to be about halfway. So let's do that. Let's go Carnation Cafe. Carnation. And whatever the reviews say, I actually think the food's pretty good there. So yeah, 0.11 miles. So if this were to explode, you would be standing, you were at Disneyland, you would be, oops, I went too far. There we are, we would be right about here. Oh, I went in the wrong direction, excuse me. Carnation Cafe is in the other direction. Here we go, closer to the Starbucks. There it is, there's Carnation Cafe on this side, and the Starbucks is over here. So that firework would have gone off right above you, right here. And in the distance, you can see Sleeping Beauty's castle. Anywho, please keep calm and math on.